Welcome to the Deep Dive, where we sift through the noise and pull out the truly interesting and important insights from the material you care about. You're here because you want to get up to speed, understand what matters, and maybe even have a few aha moments along the way without feeling like you're back in a lecture hall. Let's make that happen.
And today we are diving headfirst into the latest from OpenAI. It's their newly released Codex.
Exactly. We've got the official OpenAI announcement, the one titled Introducing Codex, and also a really good rundown from Ars Technica. So our mission basically is to get a clear understanding of what this Codex thing is, how it actually works, under the hood, and what kind of impact it could have on software development and, well, what it all means for you listening. Okay, so let's unpack this. In simple terms, what is Codex?
Okay, so OpenAI is calling it a cloud-based software engineering agent. You can think of it as like an AI that lives in the cloud, and it's specifically designed to handle a whole bunch of coding tasks.
A bunch of tasks.
And crucially, it can work on multiple things at the same time, in parallel.
Multiple tasks simultaneously. Wow, okay. That feels like a step change. So instead of me jumping between, say, writing a new feature and then context switching to fix a bug,
Right.
this cloud agent can just juggle those things.
That's the idea. It can handle things like writing new features, like you said. It can answer questions you might have about your existing code, find and fix bugs.
Okay.
And even get this, propose pull requests for code review.
Whoa, proposing pull requests.
Yeah.
That's pretty deep integration, isn't it?
It really is.
It's not just like generating little snippets of code. It's actually taking part in the whole dev workflow.
Exactly. Participating in the review process.
So where does all this happen? Does it just live somewhere vaguely in the cloud?
Well, each task you give it runs in its own separate, isolated cloud sandbox environment.
Sandbox, okay.
Yeah, and this is really important, that sandbox is preloaded with your specific code repository. So it's working right within the context of your actual project.
Ah, I see. So it's not working in some generic space. It understands my project specifics, its dependencies, all that.
Precisely.
And just to double check, this isn't the same as that Codex command line thing we heard about before, is it?
No, good clarification. This is different. This new Codex capability is built right into the ChatGPT web interface. You access it in the sidebar.
In the sidebar. Okay.
And you interact just by typing prompts, your instructions basically, and then you click either code for it to generate code or ask if you've got questions about your code.
All right, so we have a picture of what Codex is and sort of where it operates within ChatGPT. Now, the really interesting bit, how does it do all this? What's the engine driving it?
So the power behind it is something called Codex 1. OpenAI describes it as a specialized version of their O3 model.
O3, okay, their big language model.
Right. Think of that powerful model, but then further refined, specifically optimized for software engineering tasks. And a key part of that was training it using reinforcement learning.
Reinforcement learning.
Yeah, on a huge data set of real-world coding examples.
So it learned by looking at tons and tons of actual code, getting feedback, almost like how a human developer learns and gets better.
Essentially, yeah. That's a good analogy. And this training means Codex 1 learned not just, programming syntax, but also how to mirror common human coding styles. It even understands the kind of conventions and preferences you see in pull requests. Plus, it's trained to follow your instructions carefully and to iteratively test the code it generates. Make sure it works.
Iteratively test. Okay, so walk me through it. Let's say I ask Codex to write, I don't know, a new helper function. I type my prompt in ChatGPT, click code.
Yeah.
Then what's happening behind the curtain?
Right. So once you hit code, Codex spins up that isolated sandbox environment we mentioned, complete with your project's code.
Okay.
And inside that sandbox, it can read your files, it can make changes to them, and it can execute commands too. Things like running your test suites.
Like unit tests.
Exactly. Unit tests, integration tests, whatever you have. Also code linters for style checks, type checkers for correctness.
Got it. And how long does this usually take? I mean, is it instant or?
It varies. Depends on how complex the request is, obviously. But OpenAI estimates most tasks finish somewhere between, say, 1 and 30 minutes.
1 to 30 minutes. Okay. Not instant, but potentially still faster than doing it myself sometimes.
Potentially, yeah. And while it's working, you can actually watch its progress in real time in the ChatGPT interface.
Real-time monitoring, that's good. So it's not just a black box.
No, definitely not.
And when it's done, how do I actually see what it did? How do I know if the work is any good?
So when it finishes, Codex commits the changes it made, but within its isolated sandbox. And importantly, it gives you what OpenAI calls verifiable evidence,
Verifiable evidence, like what?
like citations from the terminal logs it generated while running commands, and the output from any tests it ran. It gives you a clear trail of what it did and whether the test passed.
Okay, so it shows its homework. That's pretty crucial for building trust, I guess.
Absolutely.
So after I look at this evidence, this log, what then? Do I just blindly...
There's a review stage built in. You examine the changes. You can ask for revisions if something's not quite right.
Oh, okay.
Or you can open a pull request directly in GitHub to merge it into your main project. Or, just pull the changes down to your local machine manually. You're still in control.
Right, the developer is still the gatekeeper. That's reassuring. You also mentioned configuring the environment. How specific can I get with that?
You have options within the interface to set up its environment so it closely matches your real development setup. Making sure it has the right dependencies, the right versions, the configurations your project needs.
Okay. And what about these agents.md files you mentioned? Sounds like giving the AI homework.
Yeah, sort of. Think of them like readme.md files, but written for Codex. They're just text files you can put in your repository. And you use them to give Codex context. Tell it about your code-based structure, the specific commands to run for testing, project coding standards, style guides.
Like an onboarding doc for the AI.
Exactly. A project-specific guide for your AI collaborator. It's a neat idea.
It is smart. But what if my project doesn't have one? Is Codex useless then?
Well, interestingly, OpenAI's internal tests suggest that the underlying model, Codex 1, actually performs pretty well even without these AGENTS.md files or any other special project scaffolding.
Oh, really?
Yeah. So while the files definitely help by providing more context, they're not strictly required for it to work. It is a good baseline understanding.
That's good to know. Okay, inevitable question time. Safety and trustworthiness. This is AI writing code. How are they handling that?
Yeah, huge topic. OpenAI is stressing that this is a research preview, and they're putting a lot of emphasis on security and transparency. The fact that you can verify its work through those logs, the test results, that's fundamental. As these AI models get better at complex coding, that kind of verifiability is just essential, isn't it?
Absolutely. You need to know why it did something, not just what it did. You mentioned it communicates uncertainties. How does that actually play out?
So if Codex isn't sure about something in your request, or if the tests it runs fail, it will actually tell you. It flags those issues, which lets you make a better decision. Maybe refine your prompt, maybe dig into the code it generated more carefully.
So it doesn't pretend to know everything. It raises its hand if there's a problem.
Pretty much, yeah.
But ultimately, the responsibility for checking the code, making sure it's secure, correct, that still rests with the human developer, right?
100%.
Yeah.
OpenAI makes that very clear. You absolutely must manually review and validate everything the agent generates before you merge it or deploy it. It's a tool, a powerful assistant, but human oversight is non-negotiable.
Got it. What about just producing good code? Code that follows standards, that's readable. We've all seen AI text that's off.
Right. Well, aligning with human coding preferences was apparently a big goal when training Codex 1. OpenAI says that compared to their older O3 model, Codex 1 generates cleaner patches, more readable, easier to review, easier to integrate.
Okay, that's a big plus for team adoption. Now, the really critical one, misuse, malware. How do you stop someone using this to create harmful stuff?
Yeah, top priority, obviously. They've put several things in place. Codex is specifically trained to spot and refuse requests aimed at developing malicious software. They worked on teaching it to distinguish harmful intent from legitimate tasks, even if those tasks use techniques sometimes associated with malware, like low-level system stuff.
So it tries to figure out the intent behind the request.
That seems to be the goal, yes. They've also beefed up their internal policies and done a lot of safety testing around this.
Okay.
And the secure execution environment itself is a major preventative measure.
How does the environment help with safety?
Well, the agent runs in that totally isolated container in the cloud, remember?
Right.
During task execution, internet access is completely cut off, disabled.
Yeah.
So it can only interact with the code you provided from your repo and any dependencies you explicitly set up.
So it can't call out to random websites or APIs.
Exactly. No external access. That massively reduces the potential attack surface.
Okay, that sounds like a pretty sensible security model. Let's pivot a bit. How is this actually being used? Who's got their hands on it early? And what are they doing?
Well, first off, OpenAI's own technical teams have been using it internally in their daily work.
eating their own dog food, so to speak.
Right. And they found it really useful for those kind of repetitive but well-defined tasks that often break your flow. Things like refactoring code, renaming variables across a project, writing unit tests.
The necessary grunt work.
Exactly. The stuff it needs doing but isn't always the most exciting. So it frees up their engineers for more complex problem solving.
Makes sense. What else?
They're also using it to scaffold out new features, wire up different components, track down bugs, even draft initial technical docs.
Drafting docs, too. Interesting.
Yeah. And it's apparently leading to new habits, like using Codex to help triage on-call issues or plan tasks for the day, or just offload background coding work so they can stay focused.
Fewer context switches, maybe? Staying in the zone longer?
That seems to be a key benefit they're reporting. Less context switching, surfacing forgotten to-dos, helping engineers ship faster and stay focused.
And they've worked with external testers, too, right? Not just internal use.
Yes, they've collaborated with a select group of outside companies to see how Codex works across different types of code bases, different team setups, different workflows.
Okay, who have they been working with? Any familiar names?
Several, yeah. Cisco is one. They're looking at how Codex can help their teams develop ambitious ideas faster, evaluating it across their products. Temporal is another. They're using it to speed up feature development, debugging, testing, refactoring.
Similar uses to OpenAI's internal teams, then?
Pretty similar, yeah. They specifically mentioned how it helps engineers stay focused by running complex tasks in the background.
That background processing seems like a recurring theme. Powerful.
Definitely. Then there's Superhuman. They're using it for smaller, routine stuff like boosting test coverage, fixing integration failures. But they also found, interestingly, that it lets their product managers contribute simple code changes.
Product managers writing code.
Lightweight changes, yeah. With engineers still doing the code review, of course.
Huh. That could change team dynamics a bit.
It could. It hints at maybe democratizing some aspects of coding with the right oversight.
What about Kodiak? They do autonomous driving tech, right?
That's right. They're using Codex to help write debugging tools, which must be crucial for autonomous systems. Also improving test coverage for reliability, refactoring code to speed up development, and they also found it valuable as a reference tool, helping engineers understand unfamiliar parts of their large code base faster.
Like an AI pair programmer for code archaeology.
Kind of, yeah. Surfacing context, past changes, that sort of thing.
Yeah.
Another angle, knowledge sharing.
So across these different companies, Cisco, Temporal, Superhuman, Kodiak, the pattern seems to be offloading specific, well-scoped, often time-consuming tasks.
That's a good summary of the early use cases, yeah.
Any advice coming out of these early tests? Best practices emerging?
One key takeaway seems to be assigning well-defined, sort of self-contained tasks, and maybe even running multiple tasks across different agents at the same time.
Ah, parallelism again?
Yeah, and also just experimenting, trying different kinds of tasks, different ways of wording your prompts to see what works best. It's still early days for figuring out optimal usage.
Right, requires some trial and error. Okay, so that's the new Codex in ChatGPT, but the sources also mentioned the Codex CLI, the command line tool. Updates there too.
Yes, the CLI, that's the lightweight open source agent you run in your terminal, came out last month. Lets you use AI for coding tasks right in your local environment.
Okay.
The big update is a new, smaller version of that Codex 1 model, specifically tuned for the CLI.
Smaller? Does that mean less capable?
Yeah.
Or just faster?
It's called Codex Mini Latest. It's designed for lower latency, faster interactions in the terminal. So think quick Q&A about code, fast editing tasks.
Right.
While still being good at following instructions and matching coding style, it's now the default model in the CLI.
So optimized for speed and responsiveness for that interactive terminal use case.
Yeah, exactly. And it's also available via the regular OpenAI API if people want to use it directly.
And accessing it, is that easier now? I remember API keys could be a bit fiddly.
Yes, they've streamlined that significantly.
Yeah.
Now, instead of manually generating tokens, you can just sign in with your ChatGPT account.
Oh, nice.
Yeah, select your API organization, and it automatically generates and sets up the API key for you. Much smoother.
That removes a barrier for sure. Any perks for existing ChatGPT paid users?
Yep. If you have a Plus or Pro subscription and you sign into the CLI with your ChatGPT account, you get some free API credits to use for the next 30 days.
A little incentive to try it out. Free credits are always good. Okay, let's talk practicalities. Availability and pricing. When can people start using this new ChatGPT integration?
Okay, so Codex is rolling out now to ChatGPT Pro, Enterprise, and Team users globally.
Now.
Support for Plus and Edu accounts is coming soon. And for an initial period, access is free. no extra cost.
Free to start.
Yeah, let people try it out. After that introductory phase, they'll bring in rate limits and flexible pricing for heavier users.
Standard rollout pattern, test the waters, get feedback, then figure out pricing.
Seems like it.
What about that Codex Mini latest model for developers using the API? Any pricing details there?
Yes. For the Responses API, using Codex Mini Latest, it's priced at 1.50 cent per million input tokens.
Okay.
And $6 per million output tokens.
Yeah.
And there's also a 75% discount for prompt caching, which can save costs if you make similar requests often.
Right. Tokens being roughly bits of words or code helps developers estimate costs.
Exactly. Gives them a concrete number to work with.
Now, it's new. It's a research preview. There must be limitations, right? What can't it do yet?
Oh, definitely. It's still early days. Currently, it doesn't handle image inputs, for example. So less useful for visual front-end tasks directly from images.
Okay, no image inputs. What else?
It also doesn't really support mid-task course correction yet, meaning you can't easily jump in and guide it while it's already working on something.
Ah, so it's more like launch and forget than review, not interactive guidance during the task.
Pretty much, for now.
Yeah.
It's less like pair programming in that sense. And just the nature of delegating to a remote agent means there's latency. It takes longer than just editing code yourself in your IDE.
Right, that makes sense.
OpenAI actually suggests thinking about interacting with these agents more like asynchronous collaboration, like giving a task to a human colleague and getting the results back later.
That's a useful framing. Manage expectations. It's not instant code completion.
Exactly. Though they do expect the agents to handle more complex tasks over longer periods as the models improve.
Okay, so looking further out, what's the grand vision here? How could this change software development down the line?
Well, the big picture vision seems to be a future where developers focus more on the high-level creative work and delegate more of the routine, the well-defined, maybe even some complex but automatable tasks to AI agents like Codex. OpenAI is working on a whole suite of Codex tools for both real-time collaboration and this kind of asynchronous delegation.
They see that asynchronous multi-agent approach becoming standard.
That seems to be the direction they're pointing. This Codex in ChatGPT style could become the norm for efficient, high-quality code production. They talk about a convergence eventually.
Convergence?
Yeah, of the real-time help, like the CLI offers, and this task delegation model, all integrated smoothly into IDEs and other tools developers use daily.
So a seamless workflow. Write code, get instant suggestions, delegate bigger chunks all in one place.
That sounds like the goal, a unified experience.
What else is on the horizon? Any other future plans mentioned?
They talk about making the agent workflows more interactive and flexible, allowing developers to give feedback during a task, maybe collaborate on the strategy for how to tackle a problem, get proactive updates from the agent.
More of a dialogue with the AI agent, then.
Seems like it. And also deeper integrations with other dev tools, going beyond just GitHub to connect with issue trackers, CI/CD pipelines.
Embedding it deeper into the whole life cycle.
Right, making it a part of how software is planned, built, tested, deployed, maintained.
It really sounds like they see software engineering as ground zero for AI driving big productivity gains.
It definitely comes across that way. And they also acknowledge they're working with partners in the community to understand the wider impact.
Yeah.
How widespread adoption of these agents affects developer workflows, what skills become more or less important.
Yeah, that's the big question, isn't it? It's not just about code generation. It's about how the job itself changes, how we change.
It's a massive shift to think about. Oh, and one final technical detail they shared, maybe interesting for some listeners. They actually published the underlying Codex 1 system message.
The prompt they use internally.
Essentially, yeah, the default instructions the model operates under. They shared it so developers can understand its default behavior better, maybe even customize how Codex works for their specific needs. Like, by default, it might run all the tests in your AGENTS.md, but you could perhaps instruct it to prioritize speed over exhaustive testing sometimes.
Interesting. Gives advanced users more control.
Okay, well, to wrap up our deep dive then, it seems pretty clear Codex is a major step in AI assistance for developers. It offers this genuinely new way to think about getting coding tasks done, potentially offloading a lot and boosting productivity.
Definitely a significant development. But that caveat remains crucial. It is still a research preview. Powerful, yes. Promising, absolutely. But it needs careful oversight, validation, and understanding its current limits. Right. So here's that final thought for you, our listener, to chew on. How might tools like this fundamentally change software development work over the next few years? What new skills might you need? How might your own way of working, your learning need to adapt as these AI agents get more capable? Definitely something worth thinking about. Thanks for taking this deep dive.